Today, we'll be looking at the change of base rule. And so the change of base rule is given by this. If you have log AX, then that is equal to log BX over log BA. And what's important to note is that B can be any number, like 10, E, like whatever. It doesn't really matter, as long as the bases are the same. So I'll show you quickly on how this works. Let's say, for example, you have log 3, 2. Then this, okay, is equal to log, let's say 10, 2 over log 10, 3. Okay, so the number outside of the base, right, goes on top, and the number in the base goes at the bottom. And as I mentioned before, right, this base right here can be any number. So this is literally the same as like log 3, 2 over log 3, 3. Okay, it doesn't really matter as long as they're the same. Okay, so let's say we have this question, evaluate log 3, 8. Okay, now you can't really do this on most calculators. Well, not on mine at least, right? Because you have this log button, but then it will just say like log. And this log function in the calculator has a base of 10. So if you did log 8 in the calculator, it give you the wrong answer. So this is where the change of base comes into play. So we have log 3, 8. So this will be equal to log 10, whoops, 10, 8 over log 10, 3, right? Now this you can put in the calculator, right? Because as I mentioned before, log on the calculator is set to base 10. So if you just typed in log 8 over log 3, you should get like 1.89 to 2 decimal places. All right. All right, so let's say we have this other question. Solve 3 to the power of x equals to 5 using base 10. Okay, now you wouldn't be able to like figure this out in your head. So let's solve this using change of base rule. So I know 3x5 is the same as log 3, 5 is equal to x, right? Now I can use the change of base rule right here. So log 10, 5 over log 10, 3. Now if you punch this in the calculator, you should get 1.465 to 3 decimal places. Okay, and yeah, hopefully that made more sense as to why we use change of base rule.